So I prepared a quick presentation about useful tools for Rust, mainly in Rust. They're not entirely all in Rust. They're not entirely related to cargo and the build tools that are directly related to Rust. But they are some tools that I use pretty much every day when I'm developing software and that I pretty much find interesting. So some of the default tools that I pretty much found just a short while ago is, for example, Rust completions. It's built into the Rust Up tooling, and when you set it up and when you use it, it allows you to have full shell completion for all the cargo and Rust Up commands, which is pretty useful because then you don't have to always do dash like help and stuff like that. It's pretty simple to set it up. When you run Rust completions, Rust Up completions, it'll basically list out all the necessary information that you need to follow to set it up for either bash or fish or Z shell. Here the example is for Z shell because I'm using Z shell. And one quick note, which is pretty important, is that you need to also set up the comp init and auto load of comp init into the Z shell RC file, which is something that the official documentation doesn't really mention that well, which I had to Google around for a little bit. And then you just get proper tab completion. So this is pretty much what shows up when I double tap the tab key. And it's pretty useful. It's something that I didn't know about until yesterday, actually. So another one, obviously Clippy. Probably everyone who doesn't use Clippy. Everyone uses Clippy, right? Something that some people may not know, it has an auto-fix feature. So when you pass in the fix argument and sometimes also allow dirty argument when you don't have a clean working tree, it'll pretty much try to auto-fix a lot of issues for you. So a lot of the suggestions that it has, it can automatically apply. It's similar to cargo fix. And it can't do all of them, but 70% in my experience, like the daily issues it finds, which is pretty useful. Of course, it can also be integrated into CI, which is something I recommend doing if you have a CI. So it helps you to check the code quality a little bit. Regarding Clippy, it also has quite a few options you can tweak by using the various flags and macros within the code itself. There's a few that are on by default. There's a lot more you can turn on using the actual setting for each of them. It can get really annoying, so it's a good idea to try to find a good balance, pretty much. So next one. So this one is a tool that I found not too long ago. It's basically better tests. In some sense, it's a test runner for cargo, pretty much, or for your entire project. It can run tests in parallel. It can do a nicer sort of output for all the tests, and in general, it's got a nice CI-compatible interface you can use. Yes. Yeah. Yeah, there's a cargo fix feature as well. Yes, especially when you upgrade to a new edition, which is going to be happening in a few weeks, probably for a lot of people. It will be able to auto-fix some issues, which is pretty nice. Not all of them, but yeah, definitely. Thanks. So yeah, the next test application is pretty much just a nicer test suite for Rust. It's a bit faster. I think the benchmarks showed like 2 times faster or something like that. So yeah. Then we have Bacon, which is the software that replaced Cargo Watch. Cargo Watch was something that I think even Jakub used a few weeks ago or a few months ago. Yeah, so now that project is dead. So now this one, this one is the one that everyone uses. It can integrate with Nextest pretty well. So if you run bacon space Nextest, it'll automatically run it with a mode that also runs tests. And it shows you a nice summary, of course, but it also has a sort of a more compact view mode available, which I don't have here on the screen, but it can display things depending on your sort of terminal window size, which is pretty good. I use it all the time at work. It's faster than waiting for the language server to catch up and sort of recompile everything on the background, for me at least. So that's a really nice tool to use, I think, when developing. There's also a cargo update or cargo install update. These tools have very weird names, and I always confuse them for each other. But this is a really useful tool when you install an application using cargo install. This tool will show you what versions of those tools you have installed, and it'll also auto-update them if needed, which is really useful because there is no like real auto-update feature for something that you actually install using cargo install. So that's also a thing I'm using quite often. Cargo expand, a lot of people know. It's built into, I think, JetBrains as well. It can auto-expand declarative macros. I'm not sure if it can expand procedural ones. I don't think so. It's not as sort of detailed view as you would get if you compiled into the higher intermediate representation of the code, which, I mean, expands the code properly. But it can give you quite a nice, yes? Yeah? Nice. So, yeah, so then probably a setting there. I use it sometimes for a few sort of educational purposes mostly, but it can be useful when you're debugging something or trying to find how the declarative macro, for example, expanded. So yeah, this is an example of a hello world file, which we all know, but expanded properly. So I'm guessing that's why they made the print function a macro, because if someone saw this the first time they tried Rust, they wouldn't really want to continue with it. Cargo outdated, this is something I use also all the time. It's a thing that will allow you to see what the latest major version and or minor version of each dependency in the project can be updated to. And it's something that is just not built into, like if you do cargo update, it'll only bump the versions to the minor version. Maybe there's a way to make it do the major version, but I'm not really sure. This thing does it pretty well and also has a nice UI to it, so. Yeah? Yes, as well. Uh-huh. Yeah. 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 Yeah, because it's really annoying when you're working with something else than like Rust. I know JetBrains has the feature built in that it can show you like, oh, this package can be updated to a new major version and stuff, but nothing else pretty much has that functionality. This is something that Jakub made, and he told me he would like it to be featured, so here it is. It's his application to pretty much optimize your project depending on what you need in an easier way. So it'll pretty much allow you to choose what kind of optimization you wanna apply to your compilation, and yeah, it can be quite useful if you're building something that needs to be highly performant. There's also Cargo PGO, which also applies additional optimizations to your code. I might use that actually soon for a project in my company. And then IDEs, which is the second section, which are basically what I think are the best tools with which you can develop Rust applications. Rust Rover is a pretty good one. It is free for personal use, which is a fairly new thing for JetBrains. It's not something that they used to do, but they are starting to move slowly towards free for personal usage model. And it has a really good feature, especially with all the crate management built in. It also has really nice refactorings. You can generate nice templates for code and stuff. For me, it's way too slow. It's way too bloated. It takes like 7 gigs of RAM or more, depending on the language server as well on the background. And yeah, it's also a bit unstable because it's fairly new. But it also has features or like language support, I guess you could say, enhanced language support for TypeScript and web-based stuff. And I think databases as well. So it's ideal for if you're developing like a Tori app using the Tori framework, when you're using TypeScript for sort of the web view interface, and then on the back end you're using Rust. This is pretty much made for it in some sense. Then there's Helix, which is something I've been using for about half a year now at my work. And it's, of course, written in Rust. And it's pretty much like Vim, but it's not Vim because it uses a different key sort of scheme. It's based on the Cocoon model. So it has a different way of expressing what you want to do. I think it's easier to learn than Vim. It has a much nicer UI, and overall it's much faster. It's much easier to get set up. You don't have to you can spend like 7-10 minutes maybe, and you'll have a fully functional editor, which is really nice compared to like NeoVim. If you want to set up NeoVim with all the custom configs, and then you want to do the language server, all the plugins there, and it takes like days. And you have yeah. So it also has multi-cursor support, which is a really big thing. I don't think NeoVim has that yet. Maybe it will have it soon. But that's sort of a pretty big thing there. Tree-sitter for fast sort of working with objects in the code and stuff. So yeah, it doesn't have a plugin system yet. It'll have one soon. So for now, it can only do basic sort of Git. You see what the Git status of your file is, but you can't like undo or revert a Git change within the file and such. It's a little bit weird, but I like it. It's very easy to set up with other languages. You have a health command built into Helix. And for example, this is the health command for Rust. And it'll show you what you have installed, what's configured, what you are missing. And when you install and add all of these sort of required language servers and everything into your path, it'll automatically work. You don't have to set up anything. So even on Windows, which is a pain to work with, you can just do like winget install TypeScript dash language dash server, and it'll just work automatically after that, which is really nice. And it supports like 170 languages or something. It's like a lot of different languages depending on what you have installed. This is how the editor looks. So you can see it's very similar to Vim. It has all the modes. So you have the edit mode, you have the visual mode, and such. It also has some help when you enter a different mode or you want to perform an action. It has like this nice help pop-up. You see it has some basic git-gather support, really fast syntax highlighting and such. So yeah, it's pretty nice. And it works cross-platform as well, obviously. Then there's Zed, which is something I'm using right now along with Helix as well. It's also written in Rust, so it's trying to be faster than, for example, VS Code, which, I mean, is not that hard when you write something that's not based in Electron. And when they started out, they were focused mainly on speed and like on simplicity. And I really like the editor for that, because it's very simple. It doesn't have any bloat, but it's more feature-packed than Helix in some sense. However, then the AI hype train came, and they have pretty much taken to become the best AI-focused editor and such. So there's a lot of integrated AI features, which are actually kind of good, not that terrible. Doesn't get in the way too much, which is pretty nice. And you get like a free $10 monthly credit for some tokens and stuff. So I'm using it quite often, just like to do like simple refactors or fix some syntax when I'm missing the brackets and they're misaligned and I'm way too lazy to fix them. And I've been using it for like 2 weeks to refactor some code, and it cost me like 50 cents so far from the free credit. So it's, I don't know if you can even hit the $10 one limit pretty much. And then you can of course pay extra for more. It's only on Mac and Linux. It will be available on Windows. You can build it for Windows. It works on Windows, but it's not like super well polished. So this is like one of the rare examples of software that's not available on Windows, but it's everywhere else. Which, who would develop on Windows? Me, because I have to. So then it becomes an annoying thing, because yeah. Sometimes you have to. So yeah, it also has a Vim mode, which is really good. It's the best Vim mode aside from Vim there is, and it has multi-cursor support as well. So they really do put a lot of time into making the Vim mode work. This is a video of the editor, how it looks, or maybe an image, I guess. It's very simple again. What it does have though is very good collaboration features. So you can join, you see on the left side, the collaboration panel is open and it works literally like Discord. You have just channels, you can hop in and it has voice support and camera support and, or not camera support, but just voice support, and you can share the project within the channel. So when people join the channel, they'll see your cursor and everything. You can interact together through the editor. And you can also screen share using it, your whole screen into the channel, which is pretty cool. So it's really good. It doesn't lag. You don't have to restart it 55 times in 10 minutes like VS Code, because the syntax highlighting breaks. And yeah, it's pretty good. And it also works from Windows, which is good, cross-platform and such. You don't have to download like a 500 megabyte binary like you have to do with JetBrains when you do the code with me share. So that's also pretty nice. And then there's some terminal tools, which is the third part, which I use to make the terminal a little bit more livable. Starship. By far the best one for the whole sort of UI of the terminal. It just gives you a nice prompt. And it can do stuff like read if you are in a project. So here, for example, it can read I'm on the master branch, and it can read what version of Rust I'm using because I'm in a Rust project. So it's also written in Rust, of course. But one thing is that it requires Powerline fonts. So you either have to get a font which supports like a nerd font from a page. Oh yes, you can make your own prompt, but then you don't get the nice. Yeah, but the ASCII one, or nah. Yeah, the Powerline one I think is nice, but I think out of the box it kind of does require the Powerline fonts anyway, unless you configure it. You can get, what I do usually is I use the Berkeley Mono font myself, and then I set my terminal to a fallback font using like JetBrains fonts. So that way I get the nice Berkeley font, and then I get the almost same looking but free JetBrains font, which has all the nerd or Powerline fonts included, and it can render it fine. A lot of other nice tools like this use Powerline fonts, so it might be worth getting them. ZeliJ, that's quite an interesting tool that I don't use anymore, but I did use for a while. And it's basically a terminal multiplexer in Rust, of course. They have a really nice page where you can just see all the screencasts and tutorials where you can develop plugins. It's pretty nice. You can do floating windows, you can split. You can do it's a terminal multiplexer, but in Rust, which works pretty well, and it's easy to install and configure. So yeah, you can also try it without installing using that link. I think that's what they have on the page, so you can just download that random script and just execute it and see what it does, which you shouldn't do, but they do have it there. Another one written in Rust is Bottom, which is a better top. So it's pretty much a system monitor, and you can kill processes using it, and it's nicer, and it works well, and it's fast, and it works in the terminal, which is good. It's also cross-platform. A lot of, or pretty much all of these tools can be built on any operating system, which is, I think, the best feature of trying to convert to a Rust tool like this, is that you can just get a consistent experience, even on Windows, and these tools just work, which is really, really nice. Then ripgrep. That is a very important one. I use all the time. I've aliased my grep command to be ripgrep, so I never touch grep again. It's much faster, and it's just nicer to use, and you can also use it on Windows, and it works, which is really nice. There's also, regarding Windows, there's also the core utils sort of rewrite of all the basic tools in Rust, and that also builds on Windows. So you can get all the Unix-like tools on Windows with like cargo install core utils, and that's it. And it just automatically builds, which is really nice. And it's like 10 times as fast as grep or GNU grep, or yeah, it's pretty nice. And then there's some other tools which I didn't really want to drag on because it's just about time, the 30 minutes. But for example, Bat, which is a better cat. That's why it's called Bat, I guess. And it does a much nicer printout of all the files. A better cat, again, on every operating system. And LSD instead of LS, because, well, I don't have an image here, but it is colorful. There's a lot of colors. And you should get Powerline fonts for that one, because it's yeah, quite icon heavy. And yeah, so there's more tools I'm gonna be looking out for, and perhaps in the future, if you find this interesting, I can make a follow-up a few months from now and see where the tools I recommended ended up, if they ended up being dead, or if there's more tools that are nice and useful. And yeah, that's pretty much it. I think there's the question slide, yes. If anyone has any questions or suggestions of tools I didn't mention and you like, yes? Nushell? No.
It's a shell written in Rust which has a lot of nice features for data processing. And Starship supports it.
Really?
Yes.
Well, I can look. Yeah.
There's like two shells in Rust. There is Ion, which is the Redox shell,
Fish is also in Rust now. Yeah, that has been rewritten in Rust after like 3 years. Yeah. So there's like a whole article that I didn't finish yet because it's like 50 pages of the whole experience of how they went and rewritten basically the entire shell from C++ to Rust. And especially all the intermediate steps of having to use both C++ and Rust together. That must have been a nightmare, but it's over. So now it's... Yes. Yeah. CMake is... Yeah, I had to interact with it yesterday and... yeah. So yeah, that's it from me.
Okay, this is recording. Perfect. And it looks pretty good on the recording at least. So I would like to thank our colleague for a very nice talk. And I must say that there is one thing that does Vim emulation better than that, and that's Emacs, because Evil Mode has been written over like 15 years. So it's almost one-to-one. And this is also a good time to notice that I have misspelled the title of my talk. Okay, so I suppose let's get into it. In my typist presentation, which is an awesome Rust tool, it's like LaTeX, but it's in Rust, and it's much more portable and user-friendly, even though typesetting systems never really are that user-friendly. Okay, and of course it's rendered via Emacs because I have 3 graphical applications on my system. That's enough. Okay. So let's talk about hypermedia-driven development in Rust and what it means. And if luck will have it, I will show you some examples, like real running code, by the end of the talk. So here's a story. I like writing web applications. And the reason why I like writing web applications is because it's like instant gratification. It takes like 1 minute to see something on the screen. You know, conked out zoomer brain. However, let's say traditional, normal web development is quite boring for me. I don't like it. I don't like to do mainstream stuff in general. I'm a hipster like that. So I never do it the normal way. And because the worse you make it, the more fun it is. For example, one of the Hypermedia-driven applications I did in Shea Scheme. And Shea Scheme doesn't have, it doesn't have an HTTP implementation, and it doesn't have sockets in the standard library either. So that's where we had to start. Binding libc, you know, then you implement HTTP on top of it, and then you make the web application. Great fun. And one of the major reasons why I don't like writing things in JavaScript on the front end is this thing. Have you seen it before? These are all true. And I think it's a really interesting comparison with the notion of the Christian God. Now, one side note, a lot of people think that this is just something insane that's like predetermined, that someone said, okay, so the empty array will not equal 0 in quotation marks, or 0 as a string. But it's actually due to, well, two related concepts, which I really like, and that's implicit type conversions, or coercions, I suppose, and truthiness. Does everybody here know what truthiness is? Or not? Okay, some people are shaking their head that no. So truthiness is that you have all the values evaluate into bools. And, well, of course, either true or false. And there is a good way that you can do it, which is Scheme, because Lisp invented the concept of truthiness. And that's, you have a false value, and everything else evaluates to true. And that's super easy to understand. You can do it kinda more complicated in Python, where things like empty lists and empty dictionaries evaluate to false. Then there is the JavaScript insanity, which is like very complex, and you know, you have like, I saw like empty array equals 0, doesn't equal 0, and there is like 5 steps of conversions until you get something like 0 doesn't equal 0, and then you have that coerces to false, and false doesn't equal false. It's horrible, you know. And C has accidental truthiness, because it doesn't have really, for the longest time, it doesn't have a concept of a bool. If something is 0, it's false. If it's anything other than 0, it's true. So you can put things like pointers into if, and if it's not null, it will evaluate to true, essentially. And this is actually not undefined behavior, I think. It's, since C89, it's in the standard that null is 0. But before then, it could be really interesting, I hope. Rust solves this problem by not doing implicit type coercions at all, not even for numbers. So maybe you have seen the situation. I'll write it on the whiteboard, because, you know, someone cleaned the whiteboard and I just have to ruin it. So, you know, we have one variable, which is like let x, and it's u32, and it's 2, and we have an epsilon, which is an I32, and then let's say we have a let z, and we will not specify the type here, and we will say that it's x plus y. So Rust will scream at you and tell you, hey, this is a U32, this is an I32, convert one of them. Or both of them to something else, maybe. And the nice thing about it is that you can tell exactly what the conversions are and in what order they happen, which is not something that you can do in some other languages. I saw a really nice example in C the other day, where some guy just ran into this issue. Very surprising. There was a, let's say, an unsigned int, and the unsigned int was just something, you know, let's call it also x, and it was 5. And then there was a signed int, and it was -10. And then they had an if here, and it was if y is smaller than X. And something happens here. And this thing was happening. What's the issue, right? Do you know what's the issue? The issue is written right in the standard. If you are comparing two integers of the same size and one of them is unsigned, you convert the signed one to unsigned. So this is converted to an unsigned integer. Of course it's bigger. And this is really fun because especially if you are a new programmer, you may write this and you don't know why it's wrong. That's super weird, right? I have this smaller number here and a bigger number there, and it says that the smaller number is bigger than the bigger number? Really weird. So Rust doesn't do it. And JavaScript does a lot, and so I don't like it. And of course, as I say, we must remember that JavaScript was meant as a small programming language for adding tiny bits of interactivity to a website. That was the golden age, you know, where you just put a little bit of script that made a button blue when you clicked on it. Unfortunately, that is no longer the case. And also, JavaScript has a very interesting heritage. It's essentially self and scheme bungled together by Brendan Eich. And then they came in and they said, hey, we don't want a Lisp-in browser. We want a language that looks like Java, because that's a really popular language right now. So make it more like Java. So we added Java-like syntax, and that makes it quite confusing. You've probably never worked with another language that has prototypes, and that's because prototypes come from Self, which is a fairly niche language, mostly used for research and then some other small talk adjacent stuff. So JavaScript wasn't designed for making big, complex applications that completely take over the whole web page and just drive every part of the website. And actually what we do is we are making really thick clients when we just download, 5 million lines of JavaScript compiled into a bundle on a web page. I did some investigation, and I think that we kind of lost the plot about what web should be sometime around the time that jQuery started being overused for making whole applications. Because jQuery was a nice idea. You select an element and you do something with it. And then people said, okay, what if we just started combining tons and tons of this and just overriding the entire behavior of the application? And then someone said, what if we make jQuery able to create HTTP requests and automatically parse the JSON response? And we can render the JSON response into HTML in the front end. Terrible idea. By the way, I don't know what you think about Twitter as a social media, but they are partially responsible. They were one of the first people who put out a JSON REST API, I think all the way in like 2008. So Rust is designed for writing complex apps. It has a lot of features that make it easier to manage bigger applications. Of course, there's a cost to it. Like, you will probably write JavaScript faster than you write Rust, because Rust will just come in and say, hey, you have to handle this, and if you don't, too bad, I will not compile your program. You have to unwrap that thing. You have to handle the fact that this may fail. You have to have correct types here. I will not do the conversion automatically. But it's nice and explicit, which is good for writing complex apps, because you want to focus on the things that are important and not keep things like secret types somewhere in memory. So Rust is fairly consistent. It doesn't have those insane type conversions and other really unintuitive stuff. And you can see it in like the issues in the Rust repository, is that people really care about things being as clear as they can be and as consistent as they can be. And if something is not inconsistent, well, we will try our best to change it as much as we can. It is reasonably safe. There always is someone that says, hey, I can make an unsafe program if I open its own memory as a file on Linux with sudo privileges. Yeah, of course you can make an unsafe program. And it's a really nice exercise, rewriting the discriminant in an enum by writing into a file. You can do it, and it's safe Rust, but Rust cannot, figure out that, hey, he's trying to open its own memory as a file. So reasonably safe, let's say. And it shifts, as I mentioned, the responsibility of keeping track of a number of issues from the programmer to the compiler. And some things can eventually get really difficult to keep track of, like maybe that we handle every possible message that comes from an enum, that we have a match statements in many places that they handle it. Some easy stuff like that, and some more complex stuff like thread safety. So I don't like writing JavaScript. I don't really like writing HTML either. One thing is that I like my programs to look fairly uniform and easy to visually parse, and I don't like to have things like very separated that I have to jump around in files to figure out how something that's really tiny and doesn't need to be separated into 15 files have to be. It's also, at least for me, it's also pretty easy to make mistakes in HTML. If it could have probably happened to you if you've ever made any website, is that, you make a div and you put something in the div and it's all nice and correct, and then you close the div like this. Many times I have done this. This doesn't close the div, because I should do this, and the browser will not complain about it. It will just insert closing tags somewhere, and the website will look weird, and I'll just be staring at it and, what's wrong with it? It looks good. It's indented the way it's supposed to be, It has nice colors in the editor, but there's the issue is that I forgot the slash here to close the tag, so I'm opening another tag. So I want the language that I use for my backend, because this is let's say a backend-centric talk, is I wanted to verify that I do actually generate valid markup. At least that. Maybe it can verify, if I try to work a little bit on it, it can verify that the types of values that I put into my templates are the correct ones, but at least that I generate valid markup. The third part of the traditional web CSS, I can't really do anything about it yet, but I can use Sass, which makes the process a little bit nicer and lets me prevent myself from repeating myself. So the solution is to make your entire app in Rust and use some in-code templating engine, which is verified at compile time. And that's beautiful, because it's really nice on the GitHub page when you see like the language percentage and you have a web application with a front end and it's 85% Rust, 15% CSS. Like, well, give or take maybe some Markdown and maybe less CSS, more CSS, depends on what you're doing, how big the app is. So yeah. And we have three options for doing this. We can make a web with a static front end, which is like the most old-timey traditional way. We can use a WebAssembly front-end framework, which Rust is now starting to have quite a few of, nowhere near like JavaScript front-end frameworks. And then we can do the cool, funny stuff that gets us banned from the web dev subreddit, which is actually the case. HTML extensions are banned from the web development subreddit. Is we can make hypermedia-driven applications. So the classic static front-end is super easy. We're just returning some HTML. We have some basic level of interactivity by using all the 2 hypermedia controls that are available in default HTML. And we do full page reloads whenever the user interacts, right? So they submit a form, we reload the whole page, and what we are sending back is the result of the form being submitted. This is, what's a hypermedia control? A hypermedia control is in the context of HTML. It's an element that can trigger an HTTP request. We don't have many of them. We have just 2. We have the link, the anchor, which can trigger a GET request and just replaces the whole page with whatever is returned. If it's like a URL that actually leads somewhere, we can make anchors that are to the same page, of course, to jump around headings and so on. And then we have a form. And form can trigger a get and a post request, which is quite boring because if you know anything about HTTP, we have way more methods available that all have some semantic meaning. And for some reason, HTML like kinda stopped at HTTP 1 because HTTP 1.0 had get and post and head, which is kinda not that important. Head is the same as get, but it sends only the headers, not the data. So yeah, we have a lot more HTTP methods, and it would be super nice to use them, but unfortunately here we can't. Well, the pros and cons, did someone raise their hand? No. The pros and cons is that you can use whatever backend technology, it's super easy, HTTP 1.0 is enough, you know, and you can implement that in like an afternoon. You can make a full implementation of HTTP 1. Maybe it will not be secure, but that's a problem for someone else, like your reverse proxy. So that's very simple to implement. You don't need like a separate front-end project. You're just sending HTML from the backend, which you can have somewhere in a folder called templates and some static files. That's it. Unfortunately, it's not very interactive, and every interaction just does a full reload of the page. It's kind of annoying. Maybe you have just some nice dark page and you are reading something in the night in your bed with the computer, and you click a link and you get like a half a second flashbang before the background loads again. Some browsers do it more, some do it less. It depends also how the page is written. So it's a shame. And the worst shame is that we cannot implement the nice dynamic visual stuff that we are used from applications like all the time right now. So what do we do about it? We can use a WebAssembly front-end framework, and that lets us to do anything really that we are used to doing with JavaScript front-end frameworks. Now we can do it in Rust with WebAssembly frameworks. So everything that we could ever want and need is available to us. You can also use libraries that you are used to. Maybe you have made in your backend applications, CLI-tool, whatever, you have been making HTTP requests via the request library. Well, it's available still. You can use all the Rust stuff that you are used to, so you can make requests via the request library. No problem. You are used to that, you can still use it just like you are used to. So we can do all the nice visual stuff, we can avoid full page reload, so we can make single page applications, that's SPAs. And we have many options in Rust. We have Leptos, we have Deoxys, we have Vue, we have Sycamore. Vue is the oldest one, that's the pioneer. I heard some people say that it's kind of on life support right now. I don't know. I wrote the application in Vue, so I hope it's not dying like anytime soon. Deoxys is particularly interesting because it's more generic than just web. So you can make, for example, terminal UIs and some other vendors via Deoxys, which is really nice because I imagine that it would be very easy to port a website into a mobile application with Deoxys that renders stuff natively. And I heard that the hottest new thing right now is Leptos. It's fast, it's fairly ergonomic, and it seems to work quite well. So we have excellent code reuse. We have excellent code reuse because, you know, yes?
Are some of them based on the Elm architecture?
Yes, I think that Leptos may be the one that's most inspired. There used to be a Czech framework called Seed.rs, made by Markin Kavík, and that was like heavily inspired by Elm, but it's archived. It's no longer under active development, which is a shame because it was a really good framework. And it did the thing with the markup that I said. It redefined markups via macros, and it wouldn't compile if you didn't close stuff properly and have properly formatted attributes. So yes, Elm is popular. Sycamore maybe also inspired. U is inspired by React, like directly. And there is also a lot of mess because it used to be inspired by class-based React, and then, you know, React added functional components with functions, so they started to be inspired by that. And like you see all the different examples from those two eras, and it's it's horrible. Anyways, we have excellent code reuse. We have excellent code reuse because, you know, you define some data structures on your backend as a library, and you can just import it in your front end. So you don't need to, let's say, duplicate or keep track of the same type in two different places, one in front end, one in back end. Unfortunately, we still need to have a whole separate project for front end that we compile via the WebAssembly target, and we have to install tools for that, which is fine. Probably if you're making like a bigger application, this is a really good way to go about it. But not for smaller applications, and I like smaller applications. And we have big bundle sizes, because especially if you are doing code reuse from your backend, you have to be really careful about making sure that you don't pull in unnecessary dependencies, which can happen quite easily. And still, even despite that, the bundle sizes can get quite big, and it's not so nice. But they are working to shrink them, but they are still fairly big. So that's very, very sad. But it works really well. Like this, you can do it. You can spin up a project via Bleptos, for example, or Deoxys. Those are the heaviest development goes on in there. And it will work just perfectly fine. Yes, there is also the issue that we need to have some wire format between the backend and the front end. So maybe you will send stuff via JSON that you will parse. Maybe you will not do that and you will use RON, because, you know, why wouldn't you use RON? It's Rust talking to Rust, so use the Rusty object representation, which if you're making stuff like configs or saving structures on drive, RON, it's a crate that has the same name. It's a really nice crate for doing that. And maybe you use some binary protocol, who cares? Okay, so let me see, I have a small picture. Oh yeah, and also the major issue of this is that you still have a very thick front end because it must understand the data it is handling so it can render something out of them. So here is a picture of my small U web application. You can see that the main bundle has 1.4 megabytes, and this is in release mode, so this is supposed to be smaller, the smaller one. I think it's like 2.5 in debug mode. And you know, that's 1.4 megabytes of JavaScript, well, WebAssembly binary that I need to transfer. Then there is also a WebAssembly loading script that I need to have. That's another 7 kilobytes, not much. The other two below it are not important. That's some JavaScript library and generated style sheet for it. But it's still pretty big. I don't think that my tiny application, just to provide context, this is a ChatGPT wrapper, that this application. It just can send and render messages. So it's pretty simple, you know. And it still has a bundle that's this big. Of course, gzip will help somewhat, but it's still too big for me. Okay. So, that's trouble. Now, let's talk about hypermedia. What is hypermedia? Hypermedia is media that contains links to other hypermedia. HTML is hypermedia because it contains links, anchor links, and forms, which lead you to other media that's generated by the backend as response to whatever you send. In most general terms, hypermedia is media that contains both data and actions available on that data. Because, you know, you get back some HTML and it has anchors that lead you to other documents. So that's what you can do with it. You can go to some other place from this place. Or it has forms, and the form says you can submit data that will do something. So it contains the data and actions encoded at once. Now, if we are making like JSON web APIs, that's typically not hypermedia, that's just data. You know, we're just sending something that the front end needs to understand. Now, some time ago, I heard an interesting objections that GraphQL and gRPC could be hypermedia because, you know, the schema contains some actions that I can do, you know. GraphQL has mutations, gRPC has remote procedures. But that's not hypermedia either because the client needs to know the schema beforehand so that he or she can execute the actions. Hypermedia is something that describes the actions as it sends them. So that's what HTML is. And the question is, what if, instead of going the JSON API route, what if we extended the hypermedia model? What if we were able to encode more and different actions with the media that we send? And that's what the HTMX library does. So it generalizes HTML to be a more flexible hypermedia. So the way that it does it is it adds new attributes that you can use. So that's pretty simple. It lets us use any HTTP method on any element. So for example, here I have a button and I put an hx delete which says, if I click on this button, submit a delete to this URL. And of course, it's a minimal example. I can attach data and stuff and put conditions on where that stuff will happen and so on. It lets us prevent the other things that's not so nice about static webs, and that's full page reloads, because it lets us do partial page updates. Sometimes the people that develop HTMX, they use a weird word that they seem to really like called transclusion. So they take something out and they put something back in. So here is an example for that. I have a div, and that div specifies a target and a swap. It says whatever triggers an HTML request within this div, make it target something that has this ID, and whatever it returns, put it before the end of that element. So this is a way that we can append messages to some messages div. So we say, here I have a post on the form, and it will post to /messages, and whatever comes back, we will take the messages div and we will put it right before its closing tag. So if I had like a div, I will not write the angle stuff, but if I had like a div messages that ends somewhere here, and someone submits this form, then whatever new data I get will be added here. And that reminds me, added here. Well, what we do with HTMX is that we do not send JSON, we send HTML back and forth with the server, which is really fun, and a lot of people really hate it, but it works really well. So I submit this form, the backend will give me an HTMX enriched fragment for the new message, and I will just put it here, and it's super easy. And it means that my front end doesn't have to understand the data that I'm sending from the get-go. Now the backend is completely driving the application. And that's super nice because a lot of us Rust people are more backend oriented, and we are not good at the JavaScript web development stuff. And the nicest thing is that HTMX is super tiny. It's just 14 kilobytes the last time I checked. And I checked like a default React build, and that was like 130 kilobytes. It's almost 10 times bigger. And you still need to include your own stuff. And so this will be 14 kilobytes of JavaScript, and that's it. And also, you have no separate build steps, so you just include this JavaScript file, and that's it. You don't need to have like special Node.js, Yarn, Bun, whatever project. You don't need to build some TypeScript into JavaScript, and you just do this, include it, and then backend drives your application. That's it, super easy. HTMX was created by Carson Gross, who is an American guy from Montana, and he teaches operating system implementation and compiler design. So I would say he's more like one of my people, so to speak. And he's been the most popular teacher at the university for the last 3 years, I think. He's really funny, and I think that's part of the reason why HTMX is banned from the web dev subreddit. It's because it just makes great memes, you know. So there's that. Now, what Carson Gross said is that, hey, I'm quite an older guy. I think he's 50, maybe he's more than 50. So he isn't like a new Zoomer guy just writing JavaScript library every other week. No, this is someone who is more seasoned, and he's been there before the web, and you know, he saw how web evolved, and he said, hey, there was this guy, Roy Fielding. He used to work in NVIDIA and Google. I'm not sure where he is now. And he wrote his PhD dissertation on REST in the year 2000. He invented the term REST, which is representational state transfer, if you didn't know. He also made the Apache HTTP server with some other guys. So you have definitely seen the Apache string if you've interacted with the web for any length of time. He was also the primary architect of HTTP 1.1, and the major thing that he contributed that's like very easily visible is, if you recall, a while ago I mentioned that HTTP 1.0 only has get and post. Well, he included the other methods, he created the other methods, except one, which came much later, and that's patch. Of the like basic CRUD ones, patch was added much later. I think patch was added sometime before 2010, maybe. But it's definitely much younger than the other of the standardized methods. And so he defined REST, and he said, hey, the backend, you know, should transfer state back and forth so that we can render it on the front end. The front end should be a thin client, and the best way to be able to do thin clients is to transfer hypermedia. And it seems that no one heard him, because that's not what we are doing. We are mostly making APIs that transfer JSON. And then you need to have a thick client front end that renders the JSON into some HTML on the front end, does DOM transformation by hand essentially, and it's too bad. He helps standardize HTTP, and he has a really nice quote that was a couple years after he invented REST, and says, I am getting frustrated by the number of people calling any HTTP-based interface a REST API. Because he would tell you, no, those are not REST APIs, maybe they are slightly RESTful, but they are not REST APIs because they transfer JSON or some other binary data format. They do not transfer hypermedia. It's a shame. And this is him. He has such a nice smile in most photos. I really like him. So he invented it, and he invented a lot of other related terms. And we will see one of them now. So REST wasn't meant for JSON APIs. It was meant to be hypermedia-driven. You know, you have a big server, and the server sends you bits of hypermedia, and the hypermedia tells the client what it can do with the media on. And so you can have like really thin client, you know, it loads essentially nothing. It just has to be able to view the stuff and to execute the hypermedia controls that are included in it. And it was, by the way, in response to the thick client architecture that was common in applications before then, you know, where you would have people connected to servers, and they would have to have a really thick client that is specific to that application. And the idea of the web was, what if we could have, especially of the RESTful web, was what if we could have such a really generic client that can run all sorts of applications. You have one web browser, and you can watch videos in it, you can edit documents, you can send email, you can operate an e-shop, you can open your maps. So we have this one application that's an extremely generic client for dozens and dozens of different, hundreds, thousands of different types of applications. Super, super generic. That wasn't the thing before the web. So the server will provide both the data and controls to manipulate the data. And here is another HTMX example. We send a listing for a user, and we send a link that says edit, which will trigger some edit link, and that will redirect us to a whole big another page maybe. And maybe we just want to be able to delete him quickly, to delete John quickly. And so we have this button here that issues a delete on the user, And that's something that we cannot do in normal HTML. We cannot use HTTP like correctly semantically because we can only issue a get and post. And if we are deleting something, we should use delete. So that's the thing. He invented also another interesting term. He actually didn't invent the acronym. There is a sentence in his thesis that ends like, and something, hypermedia as the engine of application state. So it's just an end of a random sentence in his thesis, and people saw, this is a really nice quote, so let's make an acronym out of it. So it doesn't appear as this acronym in the thesis. There is just some sentence, I think it ends using hypermedia as the engine of application state, and then there's a period after it. So this is something that was kind of pulled out of it. So we have the server driving the application flow, which is what we kind of spoke about already. The client doesn't know all the different URLs of things that it can pull at upfront. It knows the one that you opened it with. And the server will send data that instructs the client that, hey, you can click on this, that's another URL. You can click on this button that will send a request to this URL, and so on, which is the case with regular old links, with anchors. But if you're making like a nice JavaScript WebAssembly application, it has to know the endpoints of your API ahead, because it needs to be able to issue requests to it to get the JSON and or whatever. So it's like a TV remote, the remote comes with the TV. It's not like, yes?
I've always been curious, maybe you know the answer. What is the actual difference between REST and HateOS?
I think that HateOS is like the result of REST, So we have REST, so we are able to transfer state, and that enables us to use hypermedia precisely to drive the state of a whole application. So I would say this is more concrete. That's like the end result that's enabled by REST. I hope that helps. Okay, so let's show how it looks. Yes?
Yeah, maybe one more comment, because your discussion is fairly theoretical, so maybe just two practical points. Like when you look at the web app architecture, the now classic one with SPAs and JavaScript logic and so on has a big advantage, which is latency. So you touch the server as often if you run a logic on JavaScript. So that's one big advantage for debugging. And it has one big disadvantage, which is you have to have models of the client.
Yeah.
So we have split models, split validations, and so on and so on. So this is the practical consideration usually when developers find them into reality. And one more comment, that with HTMX, similar approaches use, Ruby on Rails and Turbo by 7 signals. They are a little bit heretics. So they are doing something that is very similar with the Rails framework.
Yeah. So that's, we can put a list here, because HTMX is not the only one, but they are kind of being really theoretical about it. So we have Ruby on Rails, and that's Turbo, right? And we have HTMX, HTMX is like an improved version or spiritual successor of a library called intercooler. Cooler.js. And there is another one that's called Datastar. And Datastar is essentially HTMX or Turbo, whatever, plus Alpine.js. So it can do really small client-based changes as well. So it's a slightly more generic one. But Datastar is much newer. So there is not that much development around it yet.
Explain in one or two sentences what is Alpine.js?
Alpine.js is a front-end framework that lets you also put attributes on elements, but those attributes contain JavaScript that reacts to different stuff. So, you know, you could have like, let's say, you could have a button, and the button will, one button, you know, will react to being clicked by sending a request somewhere and getting something back. But sometimes you don't need to just make a request for everything and transcode everything. Sometimes you actually do want to do something interactive on the front end. So what Alpine, I hope I remember the syntax correctly, is it lets you put like xclick, and the xclick just takes JavaScript here, and maybe we will say, you know, let's say this style, color, and we set it to something. So it's a nice framework to add tiny bits of interactivity like that. And a lot of people actually use HTMX together with Alpine. If they do not use Alpine, there is a more radical and sometimes even more disliked alternative, which is called Hyperscript, made by the same people who made HTMX. And what Hyperscript does is it defines a whole different language that does this sort of stuff. I recall hearing somewhere that this language was partially inspired by COBOL, which is always terrifying, but it doesn't look that bad. Let me see if I can show you Hyperscript. If it will be so nice as to load. Yes, it will. And I'll just make it much bigger. And you can make like this stuff that you attach to an HTML element, you know, on some event, do something, and it has this like very un-JavaScripty syntax. And, you know, I can click the button and it will change color. So it's tiny bits of interactivity like that. Yes. Yes, but there is stuff that you cannot do using that. So one thing that I've used Hyperscript for was, for example, cleaning inputs and so on. Like removing all the values from an input when I've submitted a form. So I have a small to-do app example with HTMX. I have it here in the presentation, but I also have the app running and I can show you the code, let's say, more directly. Let me just do this. Excellent. So I have a couple choices of frameworks. I like Rocket because it's probably the shortest web backend framework that I can fit in here. It has the least boilerplate, but it's also the most magical. So it depends on if that's something that you like. Now, a big important thing is mod. Mod is a framework that does the HTML templating in Rust as compiled. And it's a really good framework. And the way that you can tell that it's a really good framework is because the author is like really into My Little Pony. So, you know, My Little Pony, a couple flags in the bio, and you know it's a good Rust application. So I make a simple structure, that's a to-do. You know, I set some ID, I set some text, and I decide whether it is done or not. Super easy. If luck will have it, I can show you the actual code for it. That should be here. And let me also do this to make it much bigger. Okay. That's the miracle of using the same thing to code and to display a PDF. Very nasty thing, but we'll be storing it in like a mutex hash map, and we'll keep track of the next ID in another mutex. This is like a very example solution. You would probably use a database, or at least you would use something that's more log-free like dash map, so you don't have to bother around with mutexes. And here I will define my to-do item template. With mod, your templates are just functions, and you can compose them exactly as you would compose functions. And it has this sort of name of the element, then the attributes, and then in brackets, you have the body of the element. So you cannot do that thing that I used to do accidentally all the time, and if you do not close it, you will get a classic Rust error that says, hey, you are not closing your brace properly here in this function. So Rust handles that for you. It has a couple syntactic quirks. So if you are including stuff in it, it needs to be in regular parentheses. And if you are considering whether to include an attribute or not, you put it into square brackets. Otherwise, whatever goes into those brackets, it's just plain Rust, no problem. And of course, this Rust will be checked at compile time that it's actually valid Rust. And this will be baked into your binary, so it is very fast. And if you even include the CSS, yes?
The question you told, like this allows us to not have that problem that you mentioned there with the teeth, where you,
Yeah.
so it's like more times that stays with HTML. There's some Rust library that does the same thing for maybe specific HTML attributes, like so one from Haskell. Like if I mistype HTML as without last E, without this.
Mm-hmm. So I don't think that mod specifically has that sort of stuff. I was writing that for myself in Rust. I'm not sure if someone else made it like properly, but it's a super nice thing that you can do. And I saw the Haskell library, and it's super cool that you can encode even more stuff. I was doing like some small checks that I would pass things through checks to validate that it's a valid URL and so on, and to tie things together. But that would be much longer here. Okay, so I have two elements that can do some HTML stuff. I have an input, which is a checkbox, and that sends a request to the toggle endpoint, which we'll see in a moment, and it swaps the inner HTML. So this is very useful. We don't want to really do any swap. There could be a none here, I suppose. Then I display the text of the to-do, and then I have a button that says delete, and if I click on it, it will actually issue a delete request to this, and it will target a to-do with a given ID, which we figure out will be this same thing. You can do also stuff like not putting an ID here, but say closest div, or maybe closest div that has a class of something. I like to use exact IDs just to be sure that I will not accidentally be deleting something that I do not want to be deleting. Now, for index, using HTMX is super easy. I just include it in a script tag. That's it. That's the whole installation. I'm super lazy, so I put the CSS in here as well. We don't need much CSS where we are going. This is HTTP 1.0 territory. And here I have a body. I have a form. The form will post the to-dos, and it will target the to-do div, and it will add the new to-dos before the end of the tag. So it will be here. And of course, we should render all the to-dos that we already are tracking. Because we can do it on the back end, so why we wouldn't do it on the back end? It will be simpler. Of course, there is like a pattern that I have seen people use. There is a HTMX attribute called hxTrigger. And what hxTrigger does is it defines when the request will be triggered on the given element. And there are same defaults, buttons have click as the default trigger. Forms have submit as the default trigger. There is one that's really fun called load. And if you do an HX trigger on load, it will execute whenever the elements load. So what some people do is they make like a div that has the load, and then it, HX gets some data, and for example, they load things piece by piece. I think it's a waste, but we could do it. Like we could have this div that will immediately replace itself with the list that it fetches from the backend. It's great fun, but we can do it on the backend, so why wouldn't we pre-render it? And that's actually all the functionality that we need. So here we make the post for to-dos. So someone gives it to me, I figure out what the next ID should be, I increment it, and I create it and save it into the hash map. Not that much nice code, but it's super simple also. And finally, I return the template. So I return this so that we can render it on the front end. Now, for deletion, super easy. I just remove it from the hash map. Goodbye. I say, OK, status. And that's it. And for toggling, I get it. I toggle the bool, and I return the re-rendered element. Perhaps I don't need to do it, but originally I did this thing where I was crossing them out if they were checked, and then I cut it because it wouldn't fit into the presentation, the space that is. And here I just start a Rocket app, super easy. If I want to run it, yeah, this is the, let's see, let's make this bigger, and let's make this bigger. I just do cargo run on it. I can restart it so you see that it actually works. It starts the web app, super easy, tells me all the nice things about the app that I might be curious about, tells me that I have this for routes, and if I take a look at it, which would be here, yes, and let's make this bigger again. Oh, that's too big. Okay, so let's reload it, and this is the clean application, and I can do just, I don't know, my to-do, I add it, whoops, not what I wanted, I toggle it, and if I look into inspect elements so I can see the network, now I untoggle it, I see that, hey, it's not very readable, is it? Well, you will have to trust me that it made a post request to toggle, and that it responded correctly, and if I reload the page, it will stay untoggled. If I toggle it, reload the page, it will be toggled. If I delete it, it will be deleted. And I reload it, and it's not there. So it works, but unfortunately, I don't know if I can make the inspector bigger. But it's a super easy app, and you see that I don't need to do full page reload, so this type of latency is fairly solved. However, of course, I'm exchanging some small bits of HTML with the server. So if I have a very slow connection, I will feel that it will take a while for the to-do appear after I clicked add. HTMX has like a placeholder functionality. It's that lets you put in some element before I get the response, and you can use it for one of two things. You can use it to show like loading bars or placeholders for stuff, or you can show the exact same element that would be added, and then it will on the background, it will finish and substitute with the actual element. So you can kind of fake low latency with it. I hope that kind of addresses your concern with the latency. You can kind of fake it. All right, so this is a super nice example. And this is a very simple, but it's a complete web app, and it has one Rust file that has 113 lines. I put this up on GitHub. It will be like 90% Rust, 10% TOML, because there is a manifest, you know. Unless I say that it's vendors, then I don't want to count it. So that's super simple. So let's go back to the presentation. Okay, so just walking through it, you know, we have the templates, we've seen that. This is exactly the same source that you have seen already. I'll just skip through it. So that leads to a very popular thing called the whole stack, and that's HTMX and whatever you like. In my case, I like Rust, so I use HTMX on Rust that I like. Because HTMX is so simple, you can use it with pretty much all languages and web frameworks, whatever, still should work with HTMX. Of course, not the big JSON web frameworks like React. That would be terrible to combine it. But you can combine it with Alpine, for example, very easily. Now, the nice thing is that we can use actually whatever you want. There is a Discord server for HTMX, and it has like a huge category of channels for different languages. I'm not sure if it's still there, but there was like a bash section, you know, where someone was making bash HTMX applications, which you can do because you can talk over TCP via bash. So, you know, you can talk to TCP, then you can do HTTP, and you're golden, you know. It's a text-based protocol, so why wouldn't you be able to do it in a shell? It is super lightweight. We have no separate JS build step. So there is two tools that I'm recommending to people who are forced to do web frontends that should be somehow interactive and that never did any web development before. And it's Alpine JS and HTMX, because it's super easy to learn. You can learn HTMX in an afternoon. There is a super short reference of all the different attributes that are available, and it just works super, super nice. There is also a fun thing called progressive enhancement, and that's you can put the HX boost element on things, and if you click links, like regular anchors, if you click links on something that is inside an HX boosted element, it will transform it into an HX request. It will fetch the response from the server, and when it's fully loaded, it will replace the DOM. So it prevents the flashbang, kind of makes it sort of a little bit like a single page application, because it will replace the DOM, it will push URL, and it will maintain history. And of course, we have nice server-driven UI, which is good for us Rust backend developers. You can make pretty, let's see, do I have it here? Yes. You can make a lot of things with HTMX, but you cannot make everything. You know, application, animations, real-time updates. You can still use WebSockets with HTMX. It has supports for them, but you are kind of sending like replacement updates, so it's not that good for like some sort of super advanced stuff. Canvas, WebGL stuff, of course, you cannot do that. And of course, no offline, you know. Unless you're running the server on the same computer, you don't do offline because you need to talk to the server. But for most, you know, CRUD type apps, HTMX is enough. I actually have a pretty big, well, it's bigger than this one. It's still a small app written with HTMX, and it's a ChatGPT wrapper, you know. And whoops, I'm stupid. Let me just quickly check that I'm in fact still logged in. It appears to be, so it's just loading a little bit slower. Well, and I will make it smaller. Okay. I think that the zoom level is shared for the local host stuff. Yeah, it is. Okay, you know, and let's see. What's a good question for a large language model? How are you? Excellent. So let's do like, hey, how are you? And let's say, I want a long response, so let's say go in depth, hopefully. So it will take a while for the Claude API to respond, and I'm loading it piece by piece, so that's fairly interactive, you know. As the backend LLM is sending me tokens, I display token by token, you know. Uh, I have it fine-tuned for my personal preferences and mental illnesses. So, you know, let's try, you know.
Why is he sick? You know he's beating you.
Considering that who's listening is experiencing at the moment, please take back a little while for lecture.
Yeah, you know, let's say something longer. Can you recite Genesis 1? Let's see if it will let me actually, or if it will refuse. This is Claude from Anthropic. Oh, hey, and you see, we get it token by token. And so the question is, how does this work? Well, let me show you. I believe, if I'm not mistaken, I did copy out the file. So, once again, let's see, let's do this, and let's make it much bigger. So, yes, I have a lot of different buttons, but the one that I care about is the loader. I should actually, oh yeah, the generating response placeholder. So, when the user submits the message, I send back this piece of HTML. And this is the actual loader, you know, that's the 3 dots, that's this element. And what this element does is it opens a SSE connection, so that server sent events, and it keeps requesting the chunks of the message and then shoving them above itself. And finally, when we get back, you know, that the message is complete, we do it by sending an update that removes this element. So I think that this is like the only type of an application where you can make the loading icon actually responsible for the loading. You know, the loading icon is actually doing the loading, which is extremely funny to me. Because if you were to like go into the inspector and delete the loading icon, or just do it by JavaScript, that it will stop loading. So you can really, it's not like plain displaying stuff. It really pulls its weight. This is a loading icon that actually does the loading. You know. And you don't see that often, I think. As I mentioned with the whole stack, you can absolutely, did I copy it in here? No, so let's put it in here. Where was it? Cons view. So as I mentioned that I like Lisp, I have the exact type of thing made in Lisp. You know, I just return a template that's encoded as S expressions. It works perfectly fine as well. You know, it's super easy. You can integrate it anywhere. I don't know why people hate it so much. Well, let's go back to the PDF. Okay, but as I said, for simple CRUD applications, HTML is enough. It is also ideal. You know, even as people who don't really do web development for work, it is sometimes nice to be able to make like a small admin panel for our application. And let's just make a very interactive one very easily. And it's driven by the backend, so I don't need to understand front end that much. There's one thing that I slightly mentioned, that I like keeping things together. And the HTMX community actually has a name for it. They call it the locality of behavior. And it's the mortal enemy of separation of concern. Which you may like or not like. But in a lot of cases that you cannot see from the elements what they do, or from one piece of code, it's not easy to track what it does. You have to go around somewhere else. Well, here you absolutely see it. It's, you know, right on the element. And of course, you probably have to structure your app that way as well, so that it makes sense with locality of behavior. There is a nice essay on it on the HTMX website called Locality of Behavior, and that's just it. These guys, they write a lot of essays for some reason. They really like it. So the nice thing is that we can reduce our tech stack to Rust and CSS, which is extremely funny. You're making a full-fledged web application, so you can make even fairly big applications And fun fact, we've mentioned Rust Rover. JetBrains really like HTMX, and they even sponsored some HTMX talks, and they sponsored Carson Gross. So they're big on HTMX. So we have the precedent here in Czech Republic, you know, that HTMX is good, because they like HTMX. You know, so before then I would have like, you know, HTML, JavaScript, CSS, Rust, and now I have Rust and CSS. Awesome, you know. Of course, I need to understand the markup, you know. The syntax is Rust, but the semantics are HTML. Otherwise, that's it, you know. I can make self-contained applications in a single project. Even nicer thing is that I can very easily make it self-contained in a single binary. So if I'm running in like a more limited environment, it's much easier to just plop down a single statically linked binary and just run it, and okay, good, I'm running an application. Now I can include SQLite in it, and voila, application that's just single binary that requires no setup from the environment. Super easy. I don't need to design API contracts between the front end and the back end, because the front end doesn't need to understand the back end. It just displays it and executes the hypermedia controls. I don't need to maintain separate code bases, which is what our colleague there mentioned, because I don't need to have the model twice. I don't need to deal with JS build tools, you know. Has anyone here ever had the misfortune of having to write a non-trivial webpack configuration? How did that make you feel, as Freud would ask?
You just get used to it.
You just get used to it, yes. I don't need to worry about serialization of the data, which is also nice. And the nicest thing, by my estimation, is, because I like lightweight stuff, is that front-end, Emacs is lightweight by today's standards. I have to defend myself preemptively. So I like lightweight stuff. Emacs is lightweight. The front end becomes a thin client again. I'm just rendering and doing basic interaction. And all business logic stays in Rust. You know, all validation has to remain mostly in just Rust. It's awesome. And I have type safety across my entire app. It's not like possible that the model on the front end would differ from the model on the back end. Nice. So here I have some very generic final points before we go to the questions. And okay, yeah. So we have complete control in a single language. We have type-safe HTML generations if we use mod. We have fairly modern interaction without having to really learn more or less complex JavaScript. And it actually lets us use JavaScript for what it was originally meant to, you know, like small glue on the front end that adds tiny bits of interactivity, because all the major logic is done by HTMX. So I have, in my projects that I do like this, I do sometimes have like small JavaScript snippets that do some little thing, you know, like clearing a field, or, for example, do you guys know Slido? It's like a question answer Q&A thing that sometimes companies use. I always grieve the brains with stupid questions. It's great fun. So I like it so much that I decided I will make a clone of it with HTMX. Unfortunately, the backend is in Lisp, but it could be very well written in Rust in 1/3 of the time. So I have like a tiny bit of, let's see if I can actually find it. If I go to this again, I should have it. Yes. So I have like a text area, and what I do is I just resize it so that the text in it is visible always as the person is typing. That's like a super tiny piece of JavaScript. It's super nice, you know. It's a couple lines, there is no complexity. I don't need to worry about type conversions. It's, you know, essentially it's 5 to 6 lines of code that actually does something. And what it does, it makes the text area as big as it needs to be to not hide the text that's being written in it. It's a little bit of nice interactivity that makes it nicer to use because I see what I'm typing. and super nice. There we go. I want main PDF. Yes. So fairly simple, maintainable architecture. Although you can absolutely make a very messy app with HTML. It's possible. You have to be cultured. Fast development cycle. And the main idea that Carson Gross mentioned is, what if there was a fork back in the road where we didn't go the big, heavy JavaScript way, but we went more into the hypermedia way. So that's something that HTMX is trying to realize. So, as I said, server delivers HTML, the client renders it, and that's it. Simple, reliable, fast, pretty much. So, it's been long probably, hasn't it? So, questions?
So besides these small projects, do you have like some use cases for bigger applications?
Well, use cases, something that's very easy are dashboards. Dashboards work quite well in HTMX. It's most cited. I heard someone making an eShop with HTMX that also works quite well, because the one thing that I didn't mention that much is that HTMX can do so-called out-of-bound swaps. So it uses hx swap OOB. And the out-of-bound swaps, they swap something different than the target. So for example, let's say I have like a login, logout functionality, and I have a login button, I have a logout button, and if I click logout, it will give me back a response that will delete the cookie with the session ID, but it will replace the logout button with the login button again, perhaps, or it will redirect me somewhere, but let's say logout, replace it with login. But also I have like some text that says, hi Lukáš, that's at the username. And I can do with the out-of-band swap, I can replace that other part of the website as well. So for example, with an eShop, what I can do is, if someone adds something to cart, I can show that it's been added to the cart, but I can also, in the top right corner, I can update the number on the cart that says how many things are in it. So you can do these bits of like interactivity in some other place. For example, in this ChatGPT wrapper that I have, when I create a conversation, I send an out-of-band swap that will add it to the list in the sidebar. So you can do these nice little things. And that lets you build this type of dashboard, not so visual applications, I would say, if that helps you see how it can be usable in slightly bigger projects.
As your project grows, how it is easy to maintain the code?
Well, it depends on how you structure it. Typically, HTMX people structure things like by concept, so they don't have all the templates separate, they don't have all the handlers separate, don't have all the models separate, but they put together the model of thing, the related fragments, and the related handlers. And when you see all the stuff at once, well, it motivates you to make smaller units that are mostly self-contained. But it's also easier to maintain because you can keep it in your head at once. So if it's like, let's say, you have an application, and let's imagine it's this square, and like the proper separation of concern, it's slicing the app this way, like different layers of the application, different types of logic. One of those is models, one of those is views, one of those is the handlers, controllers. The locality of behavior people, they want you to slice the application this way. So you have like the whole path for one part of the application together, the whole path of another part. And some people have been successful in making pretty big applications. It's not being used in like corporates that have just massive applications, but otherwise it turns out to work out fairly well, I would say. Yes, that's true. Yes?
I'm curious, when you say to a hardcore React developer, who would argue that the biggest advantage of frameworks like React, Vue.js, etc., is that the UI is functional. You don't new its state at all. You just render the UI from the state. The framework deals with the changes and DOM annotation and so on. So you would say maybe that this is too low level, too hardcore. What's your view on that?
It's definitely more low level, yes, and it can be more bug prone, but also it's not that difficult to navigate and debug, and they actually give you tools for it, and you can open something in an inspector and you see what it's trying to execute, and you see the attributes on the elements, so that tells you very easily what it's trying to do. Even without advanced debugging tools. There are some tools that, some use cases that lean more to the functional view of things, I would say. But also, there are some things that are not so nice. You know, you can have like very deep prop drilling, or you use some state manager where you're making state and mutating state. You're still mutating state, you're just re-rendering it from the state, you know, somewhere in the background.
As I'm playing the work, not that I'm thinking of all this, like,
Yeah.
I argue exactly like you.
Yeah.
Just curious, like, what you're thinking.
Yeah, you know, you can probably make a spreadsheet application with React fairly well. You know, you can, in the model, you can model like propagators, and then you are rendering the propagators as cells, which is a super nice design pattern, by the way, propagators. There's a couple nice papers, and I think some of them were co-authored by Stallman. With HTMX, it would be like absolute hell to try to make a spreadsheet to figure out what cells exactly should be updated, you know, for a given query, and you'd have to maintain all the state on hell, you know, absolute hell. You do not want to make spreadsheets. But some insane guy did a 3D engine in HTMX that just calculates the triangles on the background and replaces diffs, and then made like a Doom clone in it, you know. So Doom does in fact run on HTMX. It's terrifying, but hey, it works somehow. Okay. Another question?
Would you tell someone who isn't so comfortable that it's so easy to debug by someone else?
To debug what?
To debug or to inspect what's happening in the website by someone else, because I've had these people, I've talked to people who are not so comfortable that it's so excessive.
That HTMX is not so
Well,
nice?
not with HTMX, but with a similar concept in other cases.
Yeah, well, the thing that makes HTMX slightly more comfortable is that you actually see it in the, you see actually what it does, you know. I can go into the HTML and, okay, it's still small, but the actual actions are on the actual element here. So I can read it and I can see it always. It's not like...
And when people don't like it with their applications that they publish?
You mean when they want to hide it?
Yeah.
Too bad.
Yeah, I know the people, so.
Yeah, so with HTMX, it's much more difficult, I would say, to conceal what things do and what endpoints it is calling. You know, ultimately, you cannot hide it completely because you can see in the log where it's issuing requests and what the responses are. But I guess that here it's like fairly visible. You know, if you want to hide it, you should probably use something else. Or there was this idea I had for this, is that, you know, we are using templating in Rust, you know, and we have the backend and the front end in one place. So what if we generate the URLs and stuff randomly? You know, the application can keep track of it. It's on the backend, you know. So that works, and you know, I can regenerate it on every run. You know, I restart the application, and it will generate new stuff for everything. And it's in the same place, so it still is connected together, but everyone who was trying to reverse engineer my thing will have to figure out the IDs again until I restart the application again, you know. So you could obfuscate things this way.
My reason usually isn't that I want to obfuscate it, but I just want to use some technology and someone else has this argument to just throw it away.
Yeah. So it's fairly easy to navigate by default, but you could probably obfuscate it pretty well because it's together with the backend and you can just generate things one-to-one. You could hash IDs randomly, for example. Yes?
Just to be a question or comment, could you say that actually, like HTMLX, it's kind of it's a reincarnation of Java server pages, like, or I don't know, active pages what Microsoft has, like before, but maybe in more unified way. Yeah?
Yes. And lightweight. It's not tied to a particular backend technology. No, it's not.
Yes. That's true. Yeah.
So this is actually like super easy to implement. I have another example app, if luck will have it, and it's the one I mentioned that I did everything for, and I don't have it in my recent. So let's see, wish lists, and let's go to yes, source, and I want the library. And I think it's here probably. Let's see, will it load, will it not? Ah, it will load, and this is not the correct file. So let's go, this could be the correct file. Actually, this. Yes. Okay, let's make it bigger, and I think yes. So this is like this is like a implementation of HTTP I did. It's HTTP 1.0, so there is only get and post. And using that, I implemented a router in Lisp, you know, that finds handlers by matching the path and so on. And using that, I was able to make an app. And yes, modify the parentheses. And so this is like built from the ground up. I made the socket implementation, I made the HTTP implementation, I made the web framework implementation, and now I'm using it to send back HTMX fragments. This is a much more low-level scheme, so I don't have that nice keyword S expression HTML templating framework, but it still works. You know, I can use a string append function to just put things into the string. It still works. So it's like completely decoupled from the backend technology. It has super low requirements, you know. And if your backend technology can do WebSockets, and if it can do server-sent events, you can use it. No problem. You could use WebSockets for, well, in things that require like bidirectional interactivity. You know, maybe you are making a game, for example, like an MMO. So you could use a WebSocket for that.
Oh, I mean like HTMX, it also uses WebSockets, right?
It supports using WebSockets. If you need WebSockets, you can use WebSockets. And you know, you are sending like WebSocket requests there, and you get HTML fragments back that do substitutions. So you could use that, for example, to drive the 3D engine that I mentioned. You know, it sends back triangles, essentially. Yeah. Or maybe you could try to be like efficient about making chat. Is that you open a connection with the server and it accepts your messages and sends you back the messages of the user, and maybe notifications on the site and so on. Any other question? Or do we wrap it up? So I'm losing my voice. Yes.
Well, I don't have a question. I have a good news to everybody, and even you. Maybe you already know, but you know, after this presentation, people might be wondering, so you know, so it's cool to have like additional
Mhm.
And the answer to that question is, of course, we can have that.
Uh-huh.
And there are already works in
Yes.
progress. So there's the group of people who are in talks with the stewards of the standard,
Yeah.
whatever the work group name,
The
name is.
V3C committee.
Yeah, I think that's maybe more than one, but what? Yeah, that one.
Yeah.
And they are already talking about that, about adding actions or buttons.
Mhm.
And there is this
Talk.
prototype project called Triptych, where they're experimenting how to design something as minimal as possible so that they can get it into the standard. So maybe, if we're lucky, we will live to see, something like HTMX, but supported natively by browsers.
Mm-hmm. Yes. And that was actually one of the ideas of the authors of HTMX, is they wanted to show that maybe this would be useful to be added to the standard. Now, yeah, this looks very similar. You define an action and you define a method. And it's very poorly readable, I think, on this screen, but I don't, it's dark. Let's make it bigger. Yes. So yeah, that seems like a nice minimalist example of this, and it has the target, so you can do transclusions, which is that nice interactivity thing, I suppose.
Now you're having more and more code written by LLMs to eventually just get your answers as being false and everything to responsive
There is one, that reminded me, there is one piece of JavaScript that I like to include in my HTMX application, and it's a piece of JavaScript that tells HTMX to process responses other than the OK ones. So by default it processes like the OK new content and so on, but it will not react to the ones that are maybe in the 300 range, 500 range. So I just put this small HTMX before on load, because HTMX exposes a lot of things as events for JavaScript. So you can very easily hook into it and integrate it in other stuff. And I just tell it, these statuses bigger than 300, less than 500, you should still swap, and don't consider it an error, just process them. And then let's be really semantic with the responses that I return from the HTMX endpoints. If something is not found, I send a fragment, but I also send 404, it was not found, so on. This is a nice little thing that I like to do. Okay. Final question, if anyone has it. Okay. If not, I suppose we are done here. Thank you all.